Hi guys, today we are going to go back to the engineering economic part of the subject. So don't be sad, it's going to be easy peasy. I'm going to recap some fundamentals of engineering economy and then we will proceed to selecting alternatives using the annual worth analysis. So stay tuned. Okay, here's a recap. When we study about economy, we study the value of money. The value of money 30 years ago is not the same with the value of money now. For example, 30 years ago, 30 cent can get you a plate of mihon. But now, 30 cent, I'm not sure what you can get with 30 cent. Even a parking at Malacca will cost you 60 cent for an hour. So anyway, that's economy. So therefore, it is more convenient to study the value of money by using the cash flow diagram. The cash flow will be drawn across certain timeline. Usually it is measured in yearly basis, and any money movement during year 0, we will call it present worth or P. Any money movement at the end of the timeline, we call it future worth or F. Any consistent money movement between year 1 to the end of the cash flow timeline, we call it annual worth or A. The differences to the value of our money depends on the interest rate, which is measured in percent. All of our economic analysis are based on interest rate and time, while the worth of our money can be decided in the value of present worth or future worth or even annual worth. You can convert the value of money by using appropriate factors. For example, you can convert present worth into equivalent future worth by multiplying the present worth with the FP factor. Notice the abbreviation used, FP. It's consistent, so that's why you don't have to memorize the formula. Okay, you can also convert future worth into equivalent present worth by multiplying the future worth with the PF factor. Again, notice the abbreviation used. You can convert present worth into equivalent annual series by using AP factor. So basically, that's the idea of converting the value of money using factors. Okay, now in annual worth analysis, we are going to convert all cash flow into annual series. Let's do this. Okay, let's say you have a car. That car costs $20,000. Every year, starting year 1, you have to pay the remaining installment of $8,000 per year. Okay, you can sell the car for $5,000 at the third year. If the interest rate is 10%, find the annual worth for 1 and also 2 life cycle. So basically what we want to do is we want to convert all this cash flow into equivalent annual series. Let's see how to do it. The first thing we need to do is draw the cash flow diagram. Very important. We know the timeline for our cash flow is 3 years. Initial cost is $20,000. The money goes out of our pocket, so that is why the arrow is pointed downwards. Every year from year 1, you have to pay installment of $8,000. Consistent amount of money starting from year 1 is the annual series. On year 3, if you decide to sell the car, you can get $5,000. Money is coming in, that is why the arrow is pointed upwards. Now, there are 3 cash flow in this diagram: the present worth, the annual worth, and the future worth. You have to convert all 3 cash flow into an equivalent annual values. First, if you want to convert the P to A, you have to multiply the P with AP factor. Next, if you want to convert the F to A, use the AF factor. Finally, how do you convert annual series to A value? You don't have to convert, it's already in annual series. So, as there are 3 cash flows, make sure there are 3 components in the equation. In this case, 1 component which convert the P value, the second component which converts the F value, and finally, the annual series value are taken as it is. Okay, substitute all values in the equation with I to be the interest rate of 10% and N to be 3 years. Make sure cash flow with downward direction are represented with negative value. Okay, Now, I hope you still remember how to get the values for the control factor. Please use a formula or use the given interest table. Okay, using your calculator, you will get an equivalent annual series of negative $14,532, meaning money is going out from year 1 to year 3. In other words, all the three cash flow can be converted into an equivalent annual series of $14,532 as shown. So this is the annual series for one life cycle. How about for two life cycles? For two life cycles, you can simply multiply the cash flow into two equal cash flow diagrams. Dekat sini you see the cash flow tu membiak. All the three cash flows are exactly duplicated in the new timeline. You can simplify this part and find the net amount, by which 5,000 minus 20,000 and you will get negative 15,000 or $15,000 directed downwards. Okay, as you can see, now there are four elements in our cash flow diagram: the money during present time, the money on year 6, the annual series from year 1 to year 6, and there's one mysterious element. We are not sure, is it a present worth or is it a future worth, as it is located exactly in the middle of the timeline, which is at year 3. What you can do now with this mysterious amount of money is that you can convert it into an equivalent value at year 0. So you can use the PF factor as the value of money at year 3 will become the future worth of year 0. Okay, using the same interest rate at 10%, and our N or our time is 3 years according to the timeline, we can get the equivalent value of negative $11,269.50. We can simplify the cash flow at year 0 by summing the net amount. So the money going out on year 0 is $31,269. Okay, so all is nice. Now we can see three clear types of cash flow, which is the present money, future money, and annual series. Next, let's convert all cash flow into equivalent annual series using the same conversion method we did last time. This time around, our N would be for 6 years. So we put in all the values, find the values in the interest table, and finally we get an equivalent annual values of negative $14,532. Now, if we redraw the new cash flow diagram, it will mainly consist of the annual series. Basically, all the cash flow of initial payment lah, annual payment lah, salvage value semua tu has been converted to an all annual series. Now, compare the results between both life cycle. Both life cycle give the same annual amount, 14,532. What does it mean? It means that if you use the annual worth analysis, it will give you the same annual amount. Tak kira lah whether you use one life cycle ke, or two life cycle, or three life cycle, hatta 1000 life cycle sekalipun, you will get the same annual amount. Imagine if you use this method to compare between different alternatives. Sebelum ni, you have to make sure the timeline of your cash diagram is the same. Kena multiply the timeline so that both have the same time. Okay, kini tidak lagi. Hidup anda jadi lebih mudah dengan annual worth method. Do you remember last time about making alternatives? Let's say you have to decide between two water treatment A and water treatment B. Both of the system offered different payment package. If the interest rate is set to be 10%, which is the better alternatives? If you analyze these alternatives using either present worth or future worth method, you have to make sure the life or the years of the cash flow must be equal. Last time, you have to multiply the life cycle using the least common multiplier or LCM so that both alternatives are computed against the same life cycle. Now, with annual worth analysis, you don't have to do that anymore. Remember, the value of annual series is the same even if you use either single or double life cycle. So it makes our life easier. You only have to convert all those cash flow to equivalent annual series without having to make a clone of the timeline series. So you see, the computational process becomes shorter. And why don't you do this exercise on your own and submit it in ULearn? I'll count this as your weekly attendance. Okay, so for many engineering economic studies, the annual worth method is much more practical compared to the present worth or the future worth method. So basically, the flow of money in annual series remains the same throughout the years, regardless whether you use the timeline of 3 years, 6 years, 9 years. So because of that, it is much more easier to be understood by many individuals. So that's why when you make loans with the bank will give you the annual amounts that you have to pay every month, because it can be understood much more easily than illustrating to you the concept of future worth or present worth. Okay, so when you do the annual worth analysis, it is very easy because you will only consider one life cycle. However, you have to take note that there are several assumptions when you use the annual worth analysis. Okay, number one, we assume that the service or the maintenance activity are needed throughout the lifetime of the alternative. So in an indefinite future, we assume duit tu akan sentiasa keluar annually. Okay, the second one is that we assume that the selected alternatives will have the same pattern in the subsequent life cycle. So the same pattern as in life cycle 1, life cycle 2, life cycle 3, semuanya akan ada cash flow yang sama, cash flow pattern yang sama. Okay, and the third one, we assume that all cash flow have the same value for all life cycle. Maknanya contohnya, kalau you keluarkan initial payment at $5,000, so in the next life cycle, we assume there is also another $5,000 keluar daripada you. And then in the third life cycle pun sama juga, 5,000. We assume the value remains, except that it will change only by inflation or deflation rate. Okay? Okay, that is all for now. Don't forget to do the exercise given. So in the next video, we are going to learn about capital recovery. Capital recovery is about reselling your product or services at an amount so that kita tak rugi sangat lah, that can still recover the initial cost. Okay, till then, stay tuned. See you later, alligator.